Hey there, Ravens. Today we're going to talk about pressure and what pressure actually is. Alright, pressure simply is defined as the force exerted divided by the area that same force acts over. Alright, so pressure is equal to the force divided by area. And here are some typical units. This is pounds per square inch or kilograms per square meter. Okay, let's look at it this way. If a woman should change her shoes from sneakers to high heels, does she exert a different pressure on the floor? Well, the surface area of the sneaker, let's pull up the pen, goes like this. Okay, imagine that being her sneaker footprint. And if this woman has a weight of 110 pounds, okay, and the surface area she's exerting over is 10 inches squared, okay, that's the surface area of the sneakers, the pressure of her shoes on the floor are 11 psi, right, pounds per square inch. If this same woman should change her shoes, right, and put on a pair of high heels, there's the heel, here's the front portion of her shoe. Okay, we could easily say that the amount of surface area of shoe hitting the floor has been reduced by half. So same woman has the same force, right? So your weight is the force of gravity pulling you towards the earth. If her surface area, because she changed shoes, reduced by half, that would be 5, right? Half of 10 is 5. And that is going to double the pressure. So it becomes 22 psi. So moral of the story here is don't get stepped on by the heel of a high heel shoe because you've got an immense amount of pressure in that small surface area. Okay, next, where does the pressure that a gas exerts come from? So it makes sense when it's shoes, but when we start talking about air molecules, it's a lot harder to understand. Okay, so here's a box, and here are a couple of molecules. Molecules of a gas, any gas you want. Okay, pressure is derived from when these molecules bounce off of a surface. And it could be the surface of the container, it could be the surface of you, it could be the surface of your desk if you're talking about the atmosphere. So every time a molecule hits a surface and bounces off, it exerts pressure on that surface. That's a bad arrow. Okay, so that's where pressure is coming from. So when we think about like the relationship between pressure and temperature is a measure of how fast particles are moving. Faster the particles move, the more pressure is going to be exerted because faster moving particles are going to bounce off the walls faster and more frequently, which will result in a higher amount of pressure. Okay. And likewise, if we should decrease the volume, right, if we reduce the size of the container, same number of particles are not going to have as much room to move around. They're going to hit the sides more frequently, which causes an increase in pressure. So just remember, pressure when it comes to gases is the number of times that molecules are bouncing off surfaces. And that's where we're getting our pressure from. All right, let's move ahead and talk about units because the units of pressure are wide and varied. Okay, one standard atmosphere of pressure, being 1 atm, is equal to 760 millimeters of mercury, 760 torr, 101.3 kilopascals. Remember, kilo represents 1,000. That's what that K is. And it's 14.69 psi. Alright, so now let's do some conversions, because when using gas laws, you have to have your units match. So if you're given two different units, you are going to have to convert so that they're all the same. Or if you're using the ideal gas law, everything needs to be in atmospheres for the R that we're using. Okay, so if we have 0.3, there's a decimal point there, 0.3 atmospheres. And we don't want atmospheres. Let's convert it to millimeters of mercury. So atmospheres goes on the bottom, and our millimeters of mercury are going to go on the top. So 760 is going to be here with our 1 atmosphere on the bottom, because 1 atmosphere is equal to 760 millimeters of mercury. And when we multiply that together, you're going to come out with 228 millimeters of mercury. Now, whether you do this in your head or you write it out on paper like I just did is totally up to you. Now, if we do torr, torr is going to be the exact same thing, only cross out millimeters of mercury and put torr, because torr and millimeters of mercury are equivalents. What about kPa, kilopascals? 0.3 ATMs. Okay, don't want ATMs. 1 ATM is equal to 101.3 kilopascals. Only the P is capitalized in kilopascals. And when we do kilopascals, we come out with 30.39 kPa. And then our last one's going to be PSI, 0.3 ATMs. Okay, and 1 ATM is equal to 14.69 PSI. And when we do that math, we end up with 4.0, no, sorry, that's 4.4. There you go, 4.4 PSI. Okay, and then there is a practice problem to do with this as well. Here is the practice problem. Example 1, the pressure of the air in a tire is measured to be 28 psi. Represent this pressure in atmospheres, torrs, and kilopascals. Whoops. Sorry about that. Going back to here, need the pen. Okay. So 28 psi, you don't want psi, so 14.69 psi are on the bottom because that's the conversion factor, and it's to 1 atmosphere. Okay, and when we do that to atmospheres, we come out with 1.9 ATMs. Okay. And next, if we do torr, again, 28 psi. Again, the 14.69 psi is going to be at the bottom, and we'll have 760 torr on top. You're going to multiply 760 by 28 and divide by 14.69, and you're going to end up with 1,449 torr. And then our last one is the kPa. So again, 28 psi's. 14.69 is still at the bottom. And that is equal to 101.3 kPa. And when we multiply and then divide, you end up with 193 kilopascals. All right, and that concludes our series on pressure. So stay tuned. Episode number 3 coming up is going to do Boyle's Law. Thank you very much.